439A. All right. So, because a lot of you didn't get the backside, let's go. All right. So, is there any questions over the front page? It says determine if the relation is a function 1, 2, 3, or 4. Any questions on 1, 2, 3, or 4? 1, 2, 3, or 4. Again, we're looking if the x value is called the domain, if the domain repeats. So problem number 1, we have -1, 0, 2, and 5. Those don't repeat, so that is a function. The second problem, we have -1, 2, and 5. So the negative ones repeat in the x in the domain, so that is not a function. But the relation just means you have x, y values. You have ordered pairs. You have some sort of points.
Wait, 1 was a function.
Yes. So 2 is not. 3, nothing repeats. So yes, number 3 is a function. Number 4 is not a function because the domain just repeats. The x's repeat. And then 5, my x values are 2, 3, 4, 5. That's a function. They don't repeat. Number 6, 3, -2, -1, and 3. So the 3's repeat on number 6 in the x value, so that is not. Number 7, you have a shape that looks like this. Well, the vertical line test doesn't work. That's not a function. You have one like this. That does work because I could draw a whole bunch of vertical lines on that. Okay, so that doesn't, so not, yes. What about a circle?
No.
Nope. Okay, what else? We have a slanted line like that. Yep.
Yes.
Then we have something that looks like that.
No.
No, because I can draw a vertical line and touch this, so that's not. And then number 12. Yes. Number 12 looks like that, so that's a yes.
Nice.
Vertical line, straight up and down, top to bottom.
That's a yas.
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 All right. So then number 13, create a relation that's a function. Okay. 1, 2, 3, 4, 5, 6, 6, 6. Is that a function?
No. I literally.
Sure it is. What repeats? Which is not part of the range, and that's okay for a function. Okay, create a function that's not.
6, 6.
7, 7, 6, 6.
I literally almost did the same thing. I did 1, 2, 3, 4, and then 5,
All right,
6, 6,
so
7.
that's not a function because the x values, which is the domain, repeats. Good. Now let's go to the back. So it sounded like a few of you had some problems over the back. So let's make sure we're okay there. Okay. All right. Problem number 15. Jot the notes down that you need on number 15, please. Okay. First question says, what is the domain? And then what is the range?
Well, that was part of it.
Oh, domain. That's part of A as well.
Wait,
Hang on, Rom. You're just speaking to hear yourself speak. No, you are.
Shut down.
I haven't even started the problem, so there's nothing that you should have a question about because the problem hadn't started, had it?
Well, I had
No, has the problem started? Gotcha. All right, so problem number 15. You have a graph that looks like this. Okay, yes, I understand there's an XY graph axis there. Okay? So, let's think about this. Let's draw our graph in. I'm going to do the best I can to draw it appropriate. Let's just pretend I drew it perfect. Okay? If I were to walk forever this way, would I continue to see the graph if I looked up? Okay? Everyone there? So the graph, if I were to continue, if I could see as far as I could see, if I continue to walk this way, I looked up, the graph exists, yes? If I continue to walk this way, and I were able to see through the ground, okay, and I looked down, could I continue to see the graph? Okay, so does anyone think that this graph is going to, like, stop or change directions?
No.
It's infinity. So my domain is going to go from negative infinity to positive infinity. I'm going to go forever to the left and forever to the right. No matter where I am to the left and wherever I am to the right means that the graph still will exist either above us, below us, or at one point actually on us, because when we get to this region, it'll be crossing through where we would be. Yeah?
Would it matter if you put negative or if you go positive, negative?
left to right, please. Okay? All right, then the range. The range is kind of like, let's say we're climbing this ladder. Okay? And the ladder goes forever up and it goes forever down. So with me? So if I were to climb forever up or forever down, and if I were to look to the right, to the left, or right on the ladder, is the graph there?
Yes.
Everyone feel good about that? So the range is going to go from negative to positive infinity in the vertical direction, the up-down direction. Okay? Does that make sense? Where I heard no.
I said yeah.
So think about it. If I were in the infinitely deep hole and I can climb that ladder that comes out of that infinitely deep hole and it goes infinitely up. If I keep looking to the right or to the left and I can see forever in either direction, does the graph exist? The answer is yes. That's why you have negative and positive infinity. Okay, so then letter B says, where on the x-axis does it appear that this graph is decreasing? Okay, so as I'm coming from this way and walking, the graph is dropping to the right. Okay, this graph has a slope that happens to be a negative slope. Okay, and we'll get a little bit there, but I just want you, if you are falling to the right, as far as a straight line goes, that's called a negative slope. So this graph is decreasing from negative infinity to positive infinity. The graph itself is pitched downward from negative infinity to positive infinity. Ram.
Wait, but from like negative infinity to 0, isn't it technically like increasing because it's going from negative?
No, the graph is decreasing. The slope of that line is negative no matter where I am on it. Okay, the entire thing's decreasing. Because if I were to say I want to find the slope, okay, we're eventually going to get the slope equation, which I know you've all seen. No matter what 2 points I pick to use the slope equation, the graph comes out to be the exact same number, and it's negative. Exact same number and negative means it's decreasing. Okay? Letter C says, what are the interval where the graph is positive? What does that mean?
It's not positive.
What do you mean? No, it is positive, but it's positive someplace.
Negative.
Where would this make sense that the graph would be positive? So it means where, if I were to plug an x value in, the output, the range, gives us a positive number. So which way is the y direction? Up, down, right, or left?
Up.
Up and down. Is there a place on this graph right now, that the graph is a positive y number? So think about the points. So I got a point there, and I got a point there, and there, and there, and there, and there, and there, and there. So think about, and there's infinite ones in between. Yeah.
I think it's from negative infinity to 12. Or not 12, 6.
3.
6. 3.
Yeah, 3's on the y-axis.
I'm going to tell you where this graph is positive.
No, but you're trying to figure out the
That
x-axis.
whole place. So it's negative
That
infinity.
line, see that pink line that's there? Yes, I understand that there's some darker red, because that encompasses the yellow dots I made. Okay? See that pink region? That pink region, the y value of that line is a positive number. Okay? So think about what I'm stating. Okay? If I were to find this point right here, this point could be like -1, which that should happen, right? -1, comma 1, 2, 3, 4, 5, 6, 7, I don't know, comma 7. That number is a positive 7. Think about the ordered pair, the point. -1, 1, 2, 3, 4, 5, 6, 7. Does that make sense? Okay? With this point is a negative number, so that could be like -2, comma, another positive number. So in this case, 8, 9, 10, positive 10. Okay? What happens right exactly here? What's the y component there?
It's not negative or positive.
It's not negative, it's 0. Okay? So this particular point, our y component right here is some x value. I don't know exactly what it is, but then the other part is 0 because it's right here, exists on the line. What is happening right here with the y values?
Negative.
They're now negative. Okay? So, where does the y value change from positive to negative? What line exists up there as far as our xy axis goes that gives us the y component now becoming negative?
The
X-axis, right. Okay? So, for letter C, it states, give the intervals on the y-axis where it is positive. Okay? So, where is it above? So, where is this line going right here? How far up is it going?
Negative. Infinity.
How far up is it going?
Infinity.
Infinity. So it's going all the way up to infinity. Where, and then we have to look at our graph, where does it appear? Okay? So in the y direction, which is up and down, okay? Give the intervals on the y-axis where the function is positive. It's all positive here. It's positive numbers here as we go up. Okay? So, from our x-axis, because this is the point, I believe, this is the point 6, 0. Let me draw this a little more clear. We have a point that exists and our graph's doing this, yes? Roughly. This is like 3, I believe. Right? So this is the point 0, 3. This is the point 6, 0. Right? So, all of this have a positive y value. Okay? So, as far as the x-axis is concerned, if I'm talking x-axis, where does it give us a positive y value? So from negative infinity to 6 is the positive y value. So how can I write the y value to give me this? Where does it go?
To infinity.
Y value.
Oh, 0 to infinity.
There you go. So how do we answer it? Give the intervals on the y-axis where the function is positive. The y values, so starting from this line, going upward, our graph is positive. So at 0 to infinity. Now, side note, is it possible that I have a line that does this?
Yes.
I could have a graph that does something like that, right? So, I don't know, I don't have our x-axis drawn in, but this could be another graph as far as our data would show. Okay, I'm just trying to show you a side note. Does this show that side note? No. Okay, but let's then look at number 16. We have, I'm going to try the best I can to draw it. I have 0, 0 as a point. Is that 3, 6? So that's way up tall.
And then 5, 4.
5, 4, thank you. So 3, 4, 5, 4.
7, 4.
And then what?
7, 4.
7, 4 comes right over here. 6, 7.
8, 1.
And then 8, 1. So this graph does this. It goes from here to here, goes here to here. It comes flat here, right? So does that look similar to number 16's graph, approximately? Okay, and if we put our points in, that point's there, and this point is 3, 6. And this point here is 5, 4. This point here is 7, 4. And this point here is 8, 1. Does everyone feel comfortable? Only thing I've changed about this graph is I made it black and green, and I wrote in the ordered pairs where the graph starts changing direction. Okay? Give the domain. Where does it appear this graph is starting in the x direction? 0. And it's going to where in the x direction? To 8. Why is it not infinity? Well, the graph doesn't continue. It's stopped. Okay? So, start, stop. Think of the range. Okay? The range is now the y values, which is 0, 6, 4, 4, and 1. Does that make sense if I said that? So what's the lowest y value?
0.
What's the highest y value?
6.
Good, 6. So from 0, so it gets to the highest point here, and then it's on its way down. So that's what how we represent our domain and range. Okay? Okay, so the range. We're looking at my y values. Okay? What's the lowest y value I have? 0. What's the highest y value?
6.
Okay, I'm not worried about the 4, 4, and the 1. They just happen to fall between 0 and 6. Okay? What are the intervals where the graph is decreasing? All right, so let's do this in purplish. Decreasing. So I'm going to show you on the graph where the graph is dropping. Here, it's decreasing, and it's also decreasing here. Why do I say that? If I found the slope of the line, the linear equation that's in between those 2 points, those would both be negative. Okay? So, give the intervals on the x-axis. So where on the x-axis is it making my graph decrease? X-axis, yeah.
3 to 5 and
Yes.
7 to 8.
So 3 to 5. And where?
7 to 8.
7 to 8. Okay? So at 3 to 7, okay? Or 3 to 5. 3 to 5, this graph is decreasing. We're looking only at the x. From 7 and 8, this is decreasing as well. Where is decreasing? Give the intervals on the y-axis where the function is positive. So where is the graph positive as far as the y-axis is concerned? Where does this go above the x-axis? Not 0 to infinity. So 0 to 6. Okay? Or is it 0 to 8? No, we got y-axis. 0 to 6. So from here to here, as I go up, I go from 0 all the way up to 6, and the graph happens to exist entirely above the x-axis. It exists above this line right here. We're looking where it's above that line right there.
What?
Cool? All right. Last ones, 17 through 26. So you're not going to see, we're going to start working more with that a little bit more, but you're nowhere, shape, or form supposed to have that mastered. Okay? So now we have this. What kind of notation is that called? What kind of notation is this called? Nope.
Oh, slope notation.
Nope.
What?
This is called functional notation. F at x, g at x, h at x. It's the same thing as saying y equals. We're just writing it in notation. Okay? So, problem number 17 says f at -3. Which of those would it make sense for me to plug -3 in for x? Which value? The first one. Why the first one?
Because it has f and x.
Yep, you're looking at that. Okay, so rather than putting x in for x, I'm putting what in for x?
-3.
Cool. Do the math. What is the function at -3? 13. What's the function doing at -3? It's getting to 13. Okay. What about f at, f at, what is the next one? F at what? 5? Which equation am I using? The first one. Why? It's f. So I have -3 times 5 plus 4. So that's -15 plus 4 equals -11. Number 19. Which of those equations am I using? First, second, or third? Second. Why? It's a g. G goes with this one. So what am I going to plug in? Rather than plugging x in, I'm plugging what in? 0. There was an x here. It's now a 0. Do the arithmetic. 2 times -3, quantity squared, plus 2. Is that okay so far? Order of operations would suggest we do the exponent next. So -3 quantity squared is 9. 2 times, and then multiplication, so 2 times 9 is 18. 18 plus 1 is 19. So the function at 0 gives us a y component of 19. What about g at 3? Which equation am I using up above? First, second, or third? Second. Why? It's g. 3 minus 3 is 0. 0 squared is 2 times 0 is 0 plus 1, 700. Good. Can I erase those first 4 problems? I want to leave the purple up there, though. Is that cool? All right. I'm at number 21 now, I believe. Which one of those equations am I using? First, second, or third? Third, the last one, right? It's an h. I'm going with the h. So that's 5 times 2. 2 is raised to the x power, so now the 2 is going to be raised to the 0. Does anybody know what 2 raised to the 0 power equals? What? What is it? 1. Good. If I raise a number to the 0 power, the answer is 1. So this becomes 5 times 1. If you plug this into your calculator, you go 2 raised to the 0, it's going to give you 1. The only number that doesn't get work is 0. 0 raised to the 0 is undefined. Okay? 5 times 1 is 5. Done.
Wait, so even if it's 3 to the 0?
3 to the 0 is 1. 10 billion raised to the 0 power is 1. Cool?
Wait, what's 2 raised to the first power?
2 to the first is 2. All right, number 22, we're on h at 3. Which equation? Third. Why? It has h. So I have 5 times 2 to the third power. 2 to the third power is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So this becomes 5 times 8, which is 23, f at negative 3. Which equation? First, second, or third? First, y. That says adds f, okay? So that's going to give me negative 3 times negative 3 plus 4. Negative 3 times negative 3 is? Positive 9. Good. That gives me 13. Okay? So you should be okay on 24, 25, and 26. Make sense? I'm going to keep the purple ones up there, but I need to do 27, 28, and 29. So let's take a look at 27, 28, and 29. Do those appear to be a little bit different presented? Agree? So number 27, x when f at x equals negative or equals 22. So which one of those, first off, which equation do you feel you might use up here? The first, second, or third? First, why? It has f at x. Okay? So we're going to use this equation because it's f at x. But this is not saying, I'm not plugging in a number for x to get it changed. F at x, what am I going to plug in for f at x? 22. So I'm now going to start substituting in for this. So 22 is equal to negative 3 plus 3x plus 4.
Oh, so we just do our normal solve.
So then we normally solve it. So from here, we'll subtract 4 from both sides. Divide each side by negative 3. So the function at negative 6 gives me 22. So now you're plugging in. So if I look at number 28, we have x when h at x equals 10. Which equation am I using? The first, second, or third? Third. Why is that? We want h at x. Okay? So I'm going to use the third equation. Where is 10 getting plugged in for?
2. Correct.
What's x? What is 10 getting plugged in for? What did 22 get plugged in for on the first one? F at x. H at x. Okay? So this is where I'm plugging in 10 now. So I have 10 equals 5 times 2 raised to the x power. Oh, shoot. I don't even know how to do this. Maybe I could divide each side by 5, maybe. That gives me 2 equals 2 raised to the x power. 2 and 2, right? What exponent should be there for this to be a true statement? 1. Think about it. Every number that sits there alone by itself is raised to the first power, unless we tell you differently. So a 1 should be there.
Wait, say it was like 4 billion. Would
Nope.
you have to like square root it?
We're not there, buddy. We're not there. 29. 29 says x when g at x equals 33. G at x. Which equation am I using? First, second, or third?
Second.
Second one. Okay. Where am I plugging 33 into?
G.
G at x. So 33 is equal to 2 x minus 3 squared plus 1. Subtract 1. Agree? Oh, and there's a 2 there, sorry. And then from there, I could probably divide by 2. These are a little tougher, but we can talk through it. 32 divided by 16 equals x minus 3 quantity squared. Okay, what number would I square to get to 16? 4 squared 16. What would I have to plug in here to make this 4? 4 minus 3 is? 1. That doesn't work. 7 minus 3 is? So what is my x value? X equals 7 in this case. Okay, and those were tougher. I'm not too concerned if you're not grabbing that at this second. Cool? Yeah.
So why couldn't you like
The squaring is kind of in the way. Let's square something. These are notes. You can hang on to that homework. I just did the whole thing. Am I collecting it? No. Why? Because I just did the whole thing. I don't need to see how well you copy. Make sense? Yeah, but I worked it out. It wasn't your work. It was mine. So put a big star at the top of your paper. And that's what will be for yours. All right, so coming out to you is graphing linear functions number 2. Ready? Set. Going. What? Okay, determine whether the relation is a function. So what can't repeat? The x, which is the domain. 0, 1, 3, 2, 1. Not a function because that and that repeat. Input is the same as x. Got it? Output's the same as y. Input's the same as domain. Output's the same as range. Problem number 2. 0, 1, 2, 3, 4. Function or not? Yes. None of those repeat. That's the first part. Make sense? Can I move on? There's it. All right. Determine whether the relation is a function. First one? Yeah. If I draw the vertical line test, I draw any vertical line in there, it touches the graph at most once. It won't touch it twice. So yes, the vertical line test passes. Problem 2, or 4, excuse me. What if I draw a vertical line out here? It doesn't touch it. But if I draw it right here, look, it touches twice. So no, does not pass the vertical line test. Yeah.
Like, what if you draw it out like where the 6 is? Then I don't know.
Well, see this line? That means it's continuing. And this means it's continuing. So, cool? Feel all right? Can I move on? Thanks, Stephen. Find the domain and range of the function represented. Okay? We have a dot here. We have a dot here. Agree? So my domain on this blue one represents x or y. X. So where does this graph start? Look at the x values. So what point is that? That's negative 1. That's negative 1, 4. Where does it end? 3, 8. Is that right? Okay, where does it start with the x?
Negative 1.
Negative 1. Where does it get to?
8. No, 3.
It gets to 3. They're both solid dots. So my domain I can actually do this way. Why am I making it a square dot?
Because they're both solid dots.
We're both solid dots. Awesome.
Wait, so we have to determine if they're solid dots or not now?
Well, yeah, I think you just have to look at it. It's not an arrow. Yeah.
The y is not 4 on the bottom because it's going by 2.
Oh, so this is, good call. So that's 2, 4, 6, 8. That's that would be a negative 8. Thank you. Because we counted by 2s, right?
Yeah.
Right? Does that make sense?
Yeah.
Negative 2, negative 4, negative 6, negative 8. That's negative 8. All right, where's my range start? It's my lowest y value. Negative 8. Where does it get to?
8.
Positive 8. Square dots or square or circle? Square around it.
Square.
Square, because I have a dot that we're including. Does that make sense? Okay, so I'm looking at my lowest y value. Okay, so I have one point being negative 1 comma negative 8, and I have another point that where it ends going to 3 to 8, 3 comma 8. The domain goes from negative 1 all the way to positive 3. So those of you saying you don't get this, look real quick. Let's go with a highlighter. Okay? So if I start here, this graph goes all the way through in the x direction. Oh, shoot. Why? Don't make it a straight line. Darn it. I didn't want that. I knew I should go to the crayon. This graph continues in the x direction as I travel in the x direction in my domain from -1, starting here, to positive 3. So -1 to positive 3, this graph exists above and below the line. The range, if I'm down here and I'm continuing on up, I have a graph that exists to the right, to the left, and right on the xy axis in that direction. Next one gets a little goofy. Why does the next one get goofy? Open dot. So does this point exist as far as our graph? Does this point exist as far as my graph? It's a hole. What about this one? It's a hole. So this graph goes, go, pick up my pencil, draw, pick up my pencil, draw. Okay, I don't. Okay, draw, pick up my pencil, put my pencil back down, draw, pick up my pencil, draw. And then yes, I'm picking my pencil up a lot. You would go like this. You would go. You wouldn't be able to see it. So this is like what this graph's doing. See these holes? That's what they're saying that in that order. Okay? So this point here is 1, 1. Agree? This point here is 2, 3. This point here is 4, 5. This point here is 6, 6.
So the first one would be 6, 1.
Okay? So I like it. Stephen, domain.
Would be 6, 1, right?
Does the domain, is it continuous? When I say continuous, can I draw my line and, or I have to pick up my pencil, right? So that takes away from being continuous. So I'm going to go from go from 1 all the way to 2, and then I have to pick up my pencil. Agree? Okay, so it's going to be a square bracket at 1. What kind of bracket is at 2? A rounded. So there. My domain will then continue. It's going to continue from here to here. What can you tell me about? 2 to what?
To 4, open bracket.
So, parentheses. And then open bracket 4 to
close bracket
6. That's my domain. What does that tell me about my domain? I had to pick up my pencil when I drew my graph. Now let's look at the range. Let's look at the range now. Okay? Now I'm looking at my y values. Agree?
Close bracket 1.
Close bracket 1 to what?
Open bracket 3.
I like it. And then where?
And then open bracket 3.
Yes.
To open bracket 5. And then open bracket 5 to close bracket 6.
Perfect.
Oh.
Steven's got it.
I got you now.
What does the parenthesis mean versus not parenthesis? I had to pick up my pencil to draw my graph. I'm just listing what's it doing with the x's, what's it doing with the y's. If I have to pick up my pencil for the x, I'm pretty sure I have to pick up my pencil for the y to draw my points.
Wait.
Mm-hmm.
How do you determine if you have to pick up your pencil with just the domain and the range?
You see the holes?
Just the domain and the range, not the actual graph.
Just if you look at it, where it's a rounded bracket means you did not include that point, so your pencil needed to come up. You drew really close to it, but you had to pick your pencil up and then to redraw. Okay? The function 2x plus 1.5y equals 18 represents the number of book raffle tickets, and x tickets x, and food raffle tickets y. Okay? So this is book, this is food. Sound okay so far? Solve the equation for y. Oh, okay. So I have 2x plus 1.5y equals 18. If I want to get y all by itself, what do I have to do? What's the first step? I'd say subtract 2x. Then how is 1.5 and y being held together right now? Multiplication. What does multiplication? Division. And as far as right now, that's going to give me y equals.
And
Can you do it? Anyone do it? And have a calculator? -2 divided by 1.5. Okay, that doesn't help me, but 2 divided by 1.5. I know it's negative. 1.3 repeating. Thank you. What's 18 divided by 1.5? 18 divided by 1.5. That'll be plus 36. 36 exactly. Sweet. We solve for y. Make an input-output table to find the ordered pairs for the function. Make it 18 divided by 1.5 is what? It's 12. Okay. So y equals -1.3x plus 12. Make an input-output table for the function. Input, output, x, y. So we got to pick some points. I don't know, -2, -1, 0, 1, 2. Is that all right? So -1.3 times -2 is 2.6. 2.6 added to 12 is 14.6. -1 times -1.3 is 1.3. 1.3 plus 12 is 13.6, or 13.3, excuse me. Plug 0 in, I get 12. Because -1.3 times that. -1.3 times 1 is -1.3. -1.3 added to 12 is 10.7, I believe. Yeah, I think we got enough. Plot the ordered pairs on a coordinate plane. So make an xy axis and plot it. -2, 14.6. -1, 13.3. 0, 12. 1. There we go. That's kind of what it would look like as far as our graph went. Okay, almost done. I think we can do this. I will hit this Monday and Monday. And I think I'm going to give you, I would like you to do this. I will mark this off for Monday. I want you to do page 67. Okay, that'll be marked off. Page 68 we will do in class. So if you have page 67 done, so it's the front, then do page 68.
68 in class, right?
67, home, 68 we will do in class.